Hi guys, in this session we are going to see how to swap two numbers without using a third variable. So let us take the numbers as x is equal to 4 and y is equal to 5. These are the two numbers. And what is meant by swapping? Swapping means interchanging of the values holding in these two variables. So before swapping it remains 4 and 5. After swapping the output will be like x is equal to 5 and y is equal to 4. Normally in any programming languages we use a third variable like a temporary variable. In temp is equal to x, store the value of x. So replace x with y, then replace y with temporary variable value. So this is how we proceed for swapping. Let us see how to swap without using this temporary variable. So the main logic involved is that XOR, which is this operator. It is one of the bitwise operator. Some of the bitwise operators are XOR, bitwise negation, bitwise logical negation, bitwise AND, bitwise OR, and some other, etc. So a big complex programming language can be made into a simple solution or much smaller solution using any of these bitwise operators. So let us see how to implement the logic for this program. Let's take input as x is equal to 4 and y is equal to 5. Now the first condition is that step 1, we need to store value of x with x XOR y. So what does it mean? X is equal to 4. So the XOR normally deals, all the bitwise operators normally deals with binary operations. So the binary representation of 4 is 100 and binary representation of 5 is 101. When doing XOR means same digits, it will be returning as 0. Different digits, it will be returning as 1. So when 4 XOR with 5, it gives like this 0 and this 1. It is taken as different digits. So when different digits, it returns 1. So 1. Then this 0, same digits. So 0. This 1, so same digits. So 0. This is the value hold in x. This is the binary representation of 1, right? So it is the value stored in x. So step 2, store the value of y as x XOR with y. So let us take, now the value of x is holding as 001. So 001 and binary representation of 5 taken as 101. So on XORing this, y holds the value as 1 1. It will be taken as same digits with 0 0 0, same digits with 0 0 and 1, same digit with different digits, so 1. So this 100 is the binary 100 is a binary representation of 4, right? Now y holds the value of 4. So step 3. Now same proceed, repeating the first step. X is equal to x XOR y. Now what is the value of x? X is stored as 1. Come on. What's the value of y? Y is stored as 4. So binary representation of 1 is 001, 4 is 100. So on computing these values, x holds the value as 10, different digits. So 1, this same digit, so 0, different digits, so 1. This 101 is a binary representation of 5. So it is, this value is holded in x. So now what is the value of x? X is equal to 5 and y is equal to 4. before the functioning, what is the value of x and y? X is equal to 4 and y is equal to 5. So the values are swapped right now. Let us take some other inputs as x is equal to 10 and y is equal to 20. Let us check this logic whether it is working correctly and how to implement in Java programming language. So let's start implementing this in Java. First, import the packages. In Python or some other advanced languages, we defaultly we have some functions called as swap, but in Java or C programming we need to implement that function as a code. So it is better to use XOR operators or some bitwise operators to do these functions. So let us take the input as x, or let us take some long inputs itself. So swap in placement point of views, it is better to use like these functional programming languages, like not writing the entire code here and implementing such functions at the back end and making operations in those functions. It is better to use like this. Return type void swap of long x long y. So perform the logic here. X is equal to x XOR y, y is equal to x XOR y, then x is equal to x XOR y. Now print the values of x and then y. So let us check how this program works. 10 and 20 values after swap 20 and 10. Let us give some other inputs as 100, 350. So after swap 350 and 100. Let us give some long inputs. So values after swap is this and this. Let us give some other big integers. So values after swap is this and this. The time of this program is about 30 milliseconds. So this is how to swap without using a third variable, simply using a bitwise operator. Thank you.